is an application problem from section 3.3, so I will just add that actually here in case you take notes and want to refer to the section. So this is from section 3.3. And the topic is systems of linear inequalities. So let's just read the problem. You're selling pizzas to raise money for a school field trip. Cheese pizzas cost $8 and pepperoni pizzas cost $9. You need to sell at least 2 of each type of pizza, and you want to sell at least $150 worth of pizzas. Okay, part A, let's just read everything. Part A says, write and graph a system of linear inequalities that describes the information given above. And part B says, you sell 12 cheese pizzas and 10 pepperoni pizzas. Did you reach your sales goal? So I guess we can answer B, obviously, after we have written and graphed an inequality, and we'll have enough information to answer B. So the first thing you probably want to do anytime you have a word problem is kind of figure out what can vary, because you're obviously going to have variables, and that's what can vary. So what can vary is how many cheese and how many pepperoni pizzas that you sell. Everything else is fixed. You know, these prices aren't going to change, and what you need, the constraints and whatnot, won't change. So I'm going to define those variables. And you can use any variables you want. I know most people choose X and Y just because it seems to be the variables that are always used. I might use C and P for cheese and pepperoni. So I'm going to say let C equal the number of cheese pizzas, and P will equal the number of pepperoni pizzas. So now that I've defined what can vary, my linear inequalities are going to be what is constrained about the problem, what can change. So I'm going to go back up to the problem, and it says you need to sell at least 2 of each pizza type. So at least 2, of course, means at the very least, so greater than or equal to. So I need to sell at least 2 cheese pizzas. I need to sell at least 2 pepperoni pizzas, and that takes care of that constraint. Then it says, and you want to sell at least $150 worth of pizzas. So cheese and pepperoni all together need to total at least $150. So cheese, or C, plus pepperoni pizzas, P, have to be at least $150. Now, I want you, I did this on purpose, this isn't quite right, and you may have caught this, but cheese pizzas and pepperoni pizzas, we've got the number of pizzas, and then we've got a dollar amount. That doesn't make sense. Pizzas don't equal money. So I need to put the cost in front of my how much one cheese pizza is and how much one pepperoni pizza is. So I'll go back and fill that in. I know a cheese pizza is $8 and a pepperoni pizza is $9. Now I have, you know, money, and that makes sense. So check your units, because sometimes that's just an easy thing to miss. And same thing here, number of pizzas, that makes sense. Then you're asked to graph it, so I'm just going to kind of squeeze down here, and you can call your axes, you know, whatever. You can call C X, you can call PX. It certainly does not matter, so whatever you prefer. So I'm just going to make cheese my x-axis and P my y-axis. And I'm going to write my constraints again down here. We wanted at least 2 of each of the pizzas, and altogether we needed to make at least $150. So C and P, obviously to graph these it would be nice to just maybe scale by ones. Well, let's solve this one for P, because P is like my Y, and just make sure that this is going to work out to scale by ones before I jump the gun and do so. So I'm going to subtract 8C over, and of course divide everything by 9. So -8/9 C plus 150 divided by 9 is about, well, 16 2/3. So 16 2/3. Sorry, I can't squeeze that in. Let me see if I can squeeze that a little bit more for you. I really can't. Okay, so 16 2/3, and we're going to approximate that anyway. So I think I'll be okay, actually, 16 2/3. So if I scaled by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16, so that's going to be all right. So yeah, I'm just going to go ahead and scale by ones. So graphing my first constraint, and I'm actually going to use different colors, so I'm going to box them in. C is greater than or equal to 2. So C equals 2 is right here, and it is a nice solid line. So that line will be right here. And that's going to be shaded to the right. So for now, I'm just going to draw an arrow saying, okay, I would shade that to the right, but I'm not going to make a huge mess quite yet. Then P is greater than or equal to 2. So P equals 2 is right here, and that's also a nice solid line. And I want to be greater than that, so it's going to be shaded above. So far my region of shading intersects right here. And then, of course, my last line, I guess I'll use green for this one, starts at approximately 16 2/3. So I'm just going to estimate that's right here, roughly, and has a slope of -8/9. So I'm going to count down 1, 2, 3, 4, 5, 6, 7, 8, and go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's approximately right here. I'll do it one more time. 1, 2, 3, 4, 5, 6, 7, 8. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's probably good. And that's also a nice solid line. And then if you're not sure where to shade this line, certainly test the point. You know, the best point, of course, to test is 0, 0. So if I put in 0 for P, if I put in 0 for C, I have is 0 greater than 16 2/3, and it certainly is not. So I'm going to shade above that line. I don't want to include 0, 0. So now I will use, well, where they all intersect would be everything above that green line and above the red line and to the right of the blue line. So the yellow there is that shaded region. Now, of course, this isn't super perfect. I mean, the green line, if I had to really pinpoint an exact point in the yellow region, I might not be so sure by my graph alone. And that's okay. Now, if I go back up here and read B, it says, you sell 12 cheese pizzas and 10 pepperoni pizzas. Did you reach your goal? Well, I know that 12 cheese and 10 pepperoni are definitely going to reach those goals. They're definitely both more than 2. So then last but not least, I want to make sure it reaches the third constraint. So I could just mathematically check $8 times 12 cheese pizzas plus $9 times 10 pepperoni pizzas need to be at least $150. And certainly that works out that this total is $186, and that's definitely more than $150. So yes, it checks. So did we reach our sales goal? Absolutely. You can, of course, go over, I'll scoop my graph up again, 12 cheese and 10 pepperoni, sorry. If I go over to 12 cheese and 10 pepperoni, I can see that I'm, you know, up here in the feasible region. So it all works out.